Hi, everyone. Welcome to Missing Pieces, tips and tricks on how to ensure your acquisitions aren't missing critical data. I am so happy to be joined today by Cesar. Um, Cesar is not only a research and development engineer at ArcPoint, but he's also a senior technical exploitation officer doing forensics day in and day out for Mantech, as well as a commander for the Army National Guard. I had the luxury of working with Cesar back at Basis Technology, and his background is well beyond that. He has a master in computer forensics from George Mason University, fellow alum, and so grateful to have him as one of the incredible reviewers on DFIR Review, and just completely honored to get to work with Cesar on this content.
Hello, everyone. Please meet Jessica, founder and owner of Hexordia. I'm sure most of you out there already know who she is, but she's also an adjunct professor at George Mason University. She's helping grow and mold the minds of the future examiners out there, doing a great job giving back to the community. Previously, she was at Magnet Forensics, Space Technology, Ernst & Young, American Systems, just a plethora of places that you can find her. She's very involved in the community, and nowadays you can find her on TikTok, so go check her out.
Yeah, on the Hexordia channel. Thanks, Cesar.
All right, here's a look at today's agenda. First, we're going to start off with the why, because we want you to know why you should care about this talk. Then we're going to hit examples of data that could be missing, specifically from hard drives and mobile devices. We'll touch on how to test to determine what you might be missing, and then we'll wrap it up at the end with some questions from the field that we can field later.
Excellent. So why do we care, right? We care because you can have data missing from your extractions. We care because when you get a collection that's incomplete, you might not have the information to say if someone's done something or hasn't done something. It is absolutely critical because we don't know what we don't know.
Right. You don't know what you don't know. And we can often say that something does exist, but we can't really say it doesn't exist. For example, you have a picture, you can see it, you have the metadata, you can, see that it exists, but you really can't say that that photo doesn't exist somewhere else. If you have it on a hard drive or if it was emailed, you can't say that it wasn't there if you don't have those pieces of evidence to examine.
Now, that's not to say that triage extractions aren't important. They are. In a lot of instances, you may need to be informing an immediate interview on scene, and you may need some information quickly to do that. You may be doing a massive scale investigation, and you're trying to determine specifically if a certain file exists on nodes, or you might be doing something where you just need to get a specific targeted acquisition and bring that data back to determine then where you're going to deep dive. There are a plethora of reasons that you would use a small collection of data to be able to do a larger deep dive examination. However, this can be a very large problem if you need to provide all exonerable content to the other side. So anytime that we need to produce evidence where somebody can demonstrate that something didn't happen, or that they weren't doing something, or that they weren't at a place, it's very difficult to do that when the collection is biased by what one party is trying to demonstrate happened on a piece of evidence. So it is important specifically in those instances to ensure that the collection is as complete a picture as possible. Also, there are many instances where a nefarious actor may be intentionally trying to hide data from you in places where they do not believe you have access. And we'll talk a little bit about that throughout this presentation.
All right, so scope with your collections. So do you want to limit your collection on your acquisitions on collection or analysis? So when we say that, when we're talking about collection, if you go out and do an acquisition and you have something from time A to time B that you're able to collect, and you focus on just that time frame on that device and you bring it back to your lab, there's potential to be missing data because you only have that specific time frame to look at. You can't connect pieces down the road because you don't have that data. So that's why we like to say it's probably a bit better to, when possible, to focus your collection, on the entire thing, and then do that scope on the analysis side. So you acquire that device as much as you can, like a file system or a full acquisition, and then you scope it to that time frame on that piece of evidence. Therefore, later on down the road, if you want to go back and collect or connect the dots, or you have something you want to follow, you have that additional data to go back and refer to.
That's such a great point. I was actually speaking with an examiner earlier today, just about this exact concept, about making sure that we are getting as full of a data set as possible on collection, that we can always limit and reduce on the analysis side. But because we don't know what we don't know, like you just said, when we're doing our analysis, neither do those tools that are capable of doing those scope down acquisitions. So in other words,
Right.
they may know about the artifacts they know about to collect, but what if your nefarious actor is using third-party applications that are unsupported by those tools? If the warrant is scoped down, it may not acquire that. Now, especially on mobile, where we're talking about records are added and deleted, so those MAC times, your created, access, and modified times may be outside of the range where records actually are being created and deleted. Never mind when primary keys are in other files that may not be pulled over from the acquisition. So really, to have that full depth of being able to actually conduct the analysis of everything that happened within the scope period of time, you are jeopardizing the scope by limiting on acquisition instead of on analysis. And I was actually speaking with somebody else. Anybody who knows Alex Caitness about this topic, actually also today, and he put a big reminder to me that this can also happen if we limit scope based on geolocation, not just time. That if we're limiting on geolocation, we can run into some of these other complexities, and that's important that if you are limiting on geolocation, that you include other down data that's happening within that regard. And just the same, that means that the collection needs to be narrowed on analysis, not on acquisition.
Absolutely. Okay, now let's go into some hard drive specific examples. And we're going to touch on some, examples, real world examples of data you could potentially be missing. So let's take an example of an external hard drive. Everybody has seen the Samsung T drives. They're pretty commonplace. They're everywhere. I've used them. I'm sure plenty of you have used them. But, even with something that's been around for a while, there's always new technology coming out. And that's can be seen with the Samsung T7 Touch, right? So this device now has a fingerprint reader on it so that a user can encrypt and lock their data. Now, even Samsung says that it doesn't have support for Linux. So if you were, doing some examination on a Linux machine and you looked up the specs for this drive, you might think that it's not going to work on your Linux machine. However, we've done testing and it shows up just fine on Linux. And this blurb here refers to the ability to actually set up the encryption on that device. Now, when you bring that device into, your forensic workstation and it's locked, you will see that what you get is a bunch of unallocated space. It's not going to show you anything. The drive is locked to you. So it's another thing to be aware of. Perhaps if you get this drive and you're not aware of that technology and you plug it in to acquire it, you're going to think that the drive is bad or something's wrong with it. It's not showing you what you're used to. But as soon as you apply that fingerprint, you'll see that everything appears just fine. It's just like a normal hard drive that you can acquire. And here's a view of it when it's locked. Again, you're not going to see any other user data except for what Samsung has provided to set up the encryption on that device.
Yeah, and in this view, it looks like it's just an unused drive to me.
Right. Absolutely. And then here, same drive, a few seconds later, you can see that and there's all the data. You can see that this drive has been plugged into a Mac at one point, but yep. And here's FTK Imager, another view of the locked drive, and there's no data for you to look at. It's unallocated space. And then here it is unlocked. And again, it shows you that there's in fact data that you could be missing if you didn't know about this newer technology that Samsung has applied to their drives.
And that's not the only instance where new technology can cause us to be unaware of what is on disk and what to expect. So one of the other newer technologies that's out there is the US 3.2 Gen 2x2s. So everyone may be familiar with the USB Gen 3.2 Gen 2, which gives us 10 gigabits per second, although you might have remembered when it was called USB 3 or when it was called USB 3.1, but that's neither here nor there.
They need to make up their minds, right?
But then when USB 3.2 2x2 came out, it gives you 20 gigabits per second. So let's say you are a leading edge person who's not a Thunderbolt user at 40, but leading edge and wanting to adopt this new technology, and you put it on your forensics workstation. And let's say on the other end that you receive a drive in evidence with this. Well, if you receive a drive in evidence that is a 3.2 drive, you actually can still make it work with a 3.0 with a 3.2 Gen 2 interface instead of a 2x2. It'll just downgrade the speed and everything will work fine, and you will be able to do a acquisition no problem. However, sometimes when you are that super technology adoption user, and you and your forensics lab have already gotten the fastest speed, thinking, this is great, it's going to allow us to write our images quicker, one of the problems you may run into is that there actually is incompatibility between both ends being fast, which is not what we'd expect, and it can result in bit drops, which means that your acquisition may actually lose bits, and you may not have a matching hash from acquisition to acquisition. So sometimes being the quickest adopter to any technology is not necessarily the best thing for forensics use, and it really stresses the importance of testing what you have and the equipment that you're going to be using on cases before you start using it on cases. But this isn't the only interface difference.
Right. So let's take, for example, adapters, right? We're all used to just grabbing an adapter, acquiring a drive, and moving about our business. But in this example, you'll see that there's these two sets of pictures are one hard drive. That hard drive is the same hard drive in those pictures. On the left, you have a StarTech adapter, and on the right, you have the hard drive and the enclosure that this drive originally came with. We just took off the case and just to show you the drive itself.
What I like about this here is you say that these are tails they can tell, and the cables look like tails.
Yeah, they have nice little tails. So when we go to image this drive, this is the StarTech adapter, and in red you can see the hash that it gives us. However, when we go and image the same drive with its original adapter that it shipped with, and you can see the hash is completely different. Now, as we all know, that shouldn't be the case. And here it is in Linux. You can see the different partitions, and Linux sees it just fine. And then we move to the hard drive adapter that it came with, and you can see that Linux is now throwing up a warning that the GPT table is corrupt, but the primary one seems okay. So in fact, what the adapter is doing, that the hard drive came with, is logically leaving out the last sector. If you notice, this instance shows one less sector than the StarTech adapter. So this screenshot is FTK Imager, and in red, you can see that last sector that I was talking about. And here is the adapter that the hard drive came with. You can see in green, that's the last part of the disk. There's nothing else after that. And what's happening is that the StarTech adapter is drive agnostic. It doesn't care what drive it is, who manufactured it, or where it came from. It's going to grab everything from A to Z. However, the hard drives that come with their enclosure, the adapters, the manufacturers are working with the adapters and doing stuff with the hard drives that they ship with to logically change what the hard drive reads. So, and that's why it's leaving out that last sector for its own metadata additions and whatever they want to add in there.
And actually, what the manufacturer adds can be important for an entirely different reason. In 2017 at the SANS-DFIR Summit, Courtney Webb gave an incredible presentation that I encourage you all to watch that was really around the implications of firmware trickery in hardware for DFIR. And there were two main things. Number one, drives can sometimes be labeled to actually have less data storage area than they actually do. So a manufacturer may choose to use one manufacturing run for all of their 512, 1 terabyte, and 2 terabyte drives, such that the space is actually 2 terabytes. And then in firmware and labeling, inform the user that the other ones are 512 and 1 terabyte. This means that if you have access to modify the firmware, you can actually hide and store data in that portion of the disk that the manufacturer is hiding to you from the firmware. Not only do manufacturers do this, but there are some exploits like HDD Hacker and others that advanced and sophisticated users can utilize to use the firmware to have the drive show a smaller size and fool your analysis tools and your acquisition tools into thinking that the drive is a smaller size based on what it's done in the firmware. And again, storing nefarious content and portions of the disk that you may not realize that you need to obtain on your acquisitions.
Right. And so another example of a hard drive that may be difficult to acquire was something that was inside a Microsoft Surface. So again, new technology is coming out. When the Microsoft Surface came out, there was really no method of acquiring this device because it had one USB port and that was it. But thanks to the community, all of you, there's a lot of sharing that goes on in the community. So a more experienced examiner who had, a little bit more knowledge in that area was able to come out with a walkthrough, a detailed step-by-step guide of what we needed to do to acquire this device. So, we had to change some security options. We needed a powered USB hub with a keyboard and a mouse and a, external drive for the acquisition. But the detailed walkthrough was extremely helpful. And instead of that piece of evidence, sitting in the lab, gathering dust, the community was able to, come up with a way to acquire the device, which is basically the same method that we use today. And that's a great win for the community.
I'm going to talk about another type of device, newer to the market. I mean, they've been around for about a decade now, but really grew in popularity in 2020. And that's Chromebooks, where Daniel Dickerman actually came up with a method for the community to do an acquisition. This method works up to version 99 of Chrome OS, and it uses a recovery method, which is great, except when you may be missing data in your collection and not know it. So the method works. However, it's putting the device into a recovery mode, and when the recovery mode writes out, it first writes to the available space left on the disk. So let's say you have a 64 gig drive of a Chromebook, and 50 of it is used. It is going to start to write out that 50 to the 14 gigs left before putting it to your target media. That means that when you get your acquisition on your target media, it's only going to be 14 gigs. The tooling and the methodology doesn't have a way of informing you or even knowing itself that it's not a complete acquisition. And so if you just took that acquisition without the knowledge that it may not be complete, and then you wouldn't know you're missing anything. So if only 14 gigs of that had been used, the 14 gigs would write out to that 50 gigs free and your acquisition would be complete. No problem. Awesome. But if that space isn't enough, you are going to have an incomplete acquisition. So what you really need to do is log in as a user and see how much storage space is available. You may choose to do this after your acquisition is completed because you at least still have a partial And if it's not complete, you're going to have to copy over to logical files anyway via that interface. So just another area where you may have an incomplete acquisition without knowing it that could have a lot of important data.
All right, so now let's move into a different category, mobile devices, something we all love and hate. We love them because they give us a lot of information, but at the same time, could be information overload, and they oftentimes prove to be a little bit difficult to get.
So if we're going to start talking about mobile, and we're going to talk about the differences between the different types of extractions and what may be missing in them, it's really important that we get out some terminology differences between the three major types of extractions. There's physical, logical, and file system, and these do not mean the same things that they mean in traditional computer forensics. I will note here that some tools use different language for this, such as full and quick, and those would fit into multiple of these categories as applicable, but we'll talk about that as we go. Also, there is a great paper out on for mobile that does a little bit of a deep dive into these three definitions that I'm going to provide. So the first one is a physical mobile forensic image. And I like to define this as data that is pulled directly from a connection to the device's storage area. So the key is that it's talking directly to the device storage area. So techniques like JTAG, or Joint Test Action Group, where you're actually soldering to and connecting to, would be included here. Chip off would be included here, but so would several boot ROM exploits, where you are actually communicating directly to the storage area of the device and pulling back data. However, these methods, physical mobile forensic images, are becoming less and less common because of the encryption on disk, because these images would be in that encrypted status if there was a hardware key. Logical mobile forensic images are very different than a logical and computer forensics. When we talk about a logical mobile forensics image, what we're talking about is a collection of data that's requested as interpreted by the operating system. This means we're requesting the data from Android or iOS in most cases. Yes, there are other operating systems, and yes, if you're requesting directly through that operating system, like PinePhone running a Linux or BlackBerry running their proprietary operating system, you would also be doing a logical image. So a logical image will include things like backups, be it an iTunes backup or an ADB process. It'll also include things like APK downgrades, where you're downgrading the Android package and requesting the data back through from this. This would include any time where you use an app-based collection, where you're pushing an application onto a device and pulling the data back. So this would include regular logical images, or quick images as labeled by your tools, as well as names like advanced logical, any of those methods where the data is being pulled back via a communication of data that has already been interpreted by the operating system. And that brings us to our third category, which is the file system mobile forensic image. Now, this is actually the primary choice of acquisitions today, because it's going to give you the fullest collection of most modern devices. And this is a collection of all the active files and folders from the file system, which may contain remnants of data and non-user data. So this will also include system partitions as well as user data partitions. And the reason that this is most comparable to a logical on a computer image. On computers, we go, we don't want a logical because it doesn't have deleted data. Yet, Jessica, you just said this includes remnants. That's right. Because in mobile forensics, we're not typically saving a document, a PDF. We're a single link file. What we're normally talking about are databases where records are written, or P-lists where records are written, or XML or JSON where records are written. So that one file can still have data that's no longer the active data being displayed, but is still on something like a free list page or elsewhere in the database that can still be carved and recovered. So since we're talking about entries at typically the record now we're doing music, the record level, it's bits and hex, or maybe it's like dual core.
There you go.
So, so because we're talking about the record level, we can still recover data, fragments, and remnants and traces, even from deleted artifacts in the full file system image. And this really is the most complete picture you'll get on most modern encrypted iOS and Android devices.
So an example that Jessica and I always like to talk about and refer to is a case that we worked in a few years back where we were able to get a physical. We looked at our device and we looked at our software. Our software told us, yes, we can get a full physical of this device. And we proceeded with that option. Meanwhile, it was acquiring. We did the regular checks on the websites. We went to GSM Arena, Phone Scoop, and those types of websites to make sure that what the tool was telling us was correct and that we were going to expect, we knew what to expect once that acquisition was complete. So those websites all told us that this phone would yield 16 gigabytes of data. So then we go back to our tool. Our tool says, hey, we're done. We got all the data, full physical, here you go. Except when we go to look at it, all we have is 1 gigabyte of data. So there's a bit of a discrepancy between what the tool told us and what the actual specs of the phone were. We're missing, 15 gigs of data at this point. However, when we're doing additional research and testing and trying to acquire this device, we ended up being able to acquire the 16 gigabytes of data on a separate chip through a Mac terminal, through using DD, right? We DD'd the image from the phone onto the Mac, and we got 16 gigabytes of data. And that was in addition to the 1 gigabyte that we already got, which was on a different chip from our acquisition tool. So in fact, in total, we got 17 gigabytes of data. So even the manufacturer's specs on the website were wrong. We had 1 gig of onboard storage and then the 16 gigabytes of eMMC that we DD'd from that phone. So it's just another example of, your tools may say that they got a full physical, which is partly correct because it's all they knew about. But, had you just relied on that and just gone about your way, you would have been missing 16 additional gigabytes of data, which is huge in a phone, right? So just always be aware and do your and research the devices that you're acquiring.
Yeah, it's such a good point because you don't know, right? You got to look.
Yeah, absolutely. And as we mentioned earlier, triage extractions are important and they do have their place, but to just solely focus on triage extractions might be, a bit of a miss if you're doing a full-blown analysis down the road, because you could be missing data that you need to link pieces together.
Yeah, so let's talk about what happens with that with the Android, right? So we'll look at the comparison between what you're getting logically and what you're getting on a full file system in a couple of categories. Now, if you're talking about the actual IMEI, MEIDs, ESNs, all of those generic GUIDs for the device, as well as the MSISEN, the phone zone number, when it can be called that, you should be able to find those things in every logical. I will note that on some Android devices, in some instances, there is issues necessarily recovering that from full file system. There's debate in the community as to why. Is it a parsing issue or a storage issue? But if you want to make sure you've got your IMEI, MEID, ESN, and your MSISDN, you can a lot of times query these directly from the device very quickly in a logical, but you should be able to get them back in a full file system. Well, no, it should. PIM data, however, the second we start talking about that, contacts, calendar, you're going to get them in both, But if you're talking about memos and notes on these Android devices, you really need that full file system to get that. And I don't know about other people, but I actually do use the notes functions on my device to very quickly take down what actually often is important things, or grocery lists, one or the other. When we talk about call logs, you're going to get this data in both types of image. And again, this actually shows why logical is very valid for triage extractions, because you'll get things like your incoming and outgoing calls, your regular pictures, images, videos. But the second you start getting to standalone files, you may not get them all in a logical. It depends on where they stored, where they came from, what they are. So in standalone files, you are going to begin missing data if you just have the logical image. That's also going to include your documents, your text, your PDFs. When you start talking about social media data, there are applications like Facebook and Snapchat where you're just not going to get those results in logical images. Those applications don't allow their data to be reported back through the operating system as interpreted data, right? When we start looking at communication apps like Signal, Facebook Messenger, WhatsApp, you need that full file system image to get that rich data. It's even going to happen to you on internet data and email. Again, you need that full file system. And if you're looking at those operating system app activity, you know, I am one of the biggest fans of both application permissions to determine what apps we haven't seen, as well as usage history. In usage history, you're just going to get some of it back. But if you're trying to say what applications have been used on this device of all time, so I can go find those applications and parse data from them, not only are you not going to have those applications unless you have the full file system, but you're not even going to know that they exist without the full file system. So you're not even going to know what you need to go after. And if you're looking for deleted data, or as like I would prefer to say, partially recovered records, because deleted is very subjective, really great paper on standards of recovery of data. If you ever want to know about it, let me know. I was honored to co-author that with Drs. Alex Nelson and Dr. Owen Casey. But at the end of the day, those deleted artifacts, just because of what we started with about the difference between the logical and full file system, they're only going to exist in that full file system.
Deleted, only hidden to the user, right? All right, now let's take a look at iOS. So where Android had the logical and file system, we're going to add a few different categories to iOS, and those are AFU and BFU. And just a primer for those who may not be aware, AFU is after first unlock. So that's a state where the phone has been rebooted and it has been unlocked at least once. And before first unlock is when the phone has been rebooted and the phone has never been unlocked. So the difference between these two states, you can still get some data, but it'll vary between the two states of what you'll get and what you can expect to get.
And I love this because we're talking about devices while they're still in a locked state and that we can get data. Now, just for clarity, there are AFU and BFU extractions on Android devices, but they're not as common. So let's talk about the differences between these. Again, when you're talking about this equipment user data, all of these great GUIDs, you're going to be able to get them from all your different extractions, including your BFU. And you can kind of see here that we've ordered these in terms of priority. And I just want to say all of this great data in terms of these extraction-specific delineations, just a huge shout out to Jay Varda from Grayshift for sharing his research and information with us to include in the presentation here with that. When we start getting into our PIM data, though, this personal information management, we can see immediately that our contacts, our calendars, and our memos and notes are not present at all in the BFU. Now, this really stresses the importance of ensuring that you are putting battery power on your devices during collection. Cesar was just explaining that the before first unlock means that the phone has rebooted. Now, and without being unlocked. You want to keep your data sets in AFU because that can even be a richer source than a logical, even if it's not locked, right? So the way to keep your data in AFU is to keep power on, because if you don't connect the charger and you put that device in the Faraday bag and it continues to try to call out to the tower with the signal blocked, that battery is going to burn down and become locked. If it becomes locked, you've now left this data-rich state of AFU and you are now in BFU. So if you've done that, you now do not have access to those contacts, calendars, memos, and notes. Oh, it's so important to keep power on, because you're also going to lose your SMS messages. You're going to lose some of your SMS messages. You're going to lose some of your MMS messages. You're going to lose some of your standalone files. So much of this data that you're going to get in AFU. Now, there are some interesting places, like when we talk about documents, you really need AFU or better, AFU or full file system to be able to get them all, but you will get some partial recovery. Partial recoveries scare me even more, because when you have partial recoveries of data, you can think you have something. Now, Apple Health is not available if the device is in a locked state, period. So AFU and BFU won't work, but you will get data back in both logical and full file system. Now, that nuance is actually the opposite when we start talking about Snapchat. Facebook, for example, and there's variance in all, just showing these two examples because there's variance in all our different social media apps in terms of how they act. But with Facebook, for example, you don't get the data in BFU and logical. You need AFU or full file system. With Snapchat, you can actually get the data in BFU or AFU, but just not in a logical. So we want to try to obtain as many extraction types as we can, but always AFU is preferable to BFU. Keep that battery on. When we start talking about other communication applications, again, when we start talking about third-party apps, we'll see variance in data. And for example, with Signal, you're going to need the AFU or the full file system to get that communication data. Now with Facebook Messenger, it's the same, but WhatsApp, both Meta products, both the same parent company, you can get data in the logical. So just note that there's going to be variance for every single third-party app. So what is your goal going to be? AFU at least, full file system if you can get the password, or you're able to brute force, or you have a tool that can do that for you, right? In terms of internet artifacts, you can see here that you definitely want the logical AFU or full file system. Now, something interesting about Safari, right, is Safari will have 30 days worth of data, and we'll talk about that a little bit later on. So you may think you have it all in your logical, but actually, while it's present in both logical and full file system, because you have the database, you can actually even carve more. So even though you have the database, if you have the full file system version, even though it's present in both, you can actually carve more than you can just out of the regular. I'm excited about it because data,
get more data.
right? Get more data. Actually, there's a little trick there, and I'll hold off on talking about it. But man, Safari is so much fun. Apple Mail. Here's an example of where you need a full file system extraction to be able to get that rich data. And I don't care how old the version of iOS is, you need that full file system to get that Apple Mail data. Apple Mail does not like us. Now let's talk about GPS, because GPS, we're always after geolocation artifacts, right? Now you're not going to get anything in your BFU. You might get some in your partial. But this is one of those instances, if you want significant locations or cache locations, you need that full file system image. So please find ways to get the tools and utilities and methods to get that full file system image. And then if you think about things like Knowledge Sea, Sarah Edwards has done so many presentations around the rich pattern of life data that you can get here. So if you want to use her tool Apollo and bring that information through, you're going to need an AFU or full file system acquisition. And it's not just Knowledge Sea, it's also AirDrop, it's also PowerLog. And then most importantly, again, those artifacts that we're just hiding from ourselves as users, those deleted artifacts, there's a possibility of recovery with AFU and full file system extractions, but you're not going to be able to get that with BFU and logical. So I hope everyone here has got the keep it charged. Make sure your first responders to the scenes are keeping those batteries on those devices so that you have that AFU state as long as it had been previously unlocked. And if possible, let's get that full file system. Let's not just rely on that triage extraction.
Right. So in an example of did the user do it, we'll take this mobile SMS plist, which shows us the iOS message retention. And this is an example of going through testing to determine, what we could potentially be missing. So iOS ships with the keep messages for days as forever. What we did is we imaged the device, we left it on forever, and the keep messages for days
You left it up forever? I'm sorry, like it's still on.
Yeah, so we left it on forever with that battery pack, right? We left it on the forever option, and the keep messages for days keys doesn't appear anywhere in that plist. So then we changed it to 1 year. We reimaged the device, and all of a sudden that keep messages for days key appears in that plist with a value of 365, obviously for 365 days in the year. So then we changed it to 30 days. We took another image of it, and then the keep messages for days key now has a value of 30. And we changed it back to forever, the option that it originally came with. And this time, instead of it not being there, the keep messages for days key is in fact there with a value of 0. So this tells us, at some point the user did change the option because that keep messages for days key appears. However, what we don't know is, when he changed it or to what different states he changed it. We just know that the user changed it at some point.
Now, all iOS retention things are not necessarily pertaining to user-selected functionality. Some of this has to do with you losing data because of default retention rates. So, for example, Safari, and I kind of hinted at this before, has only a 30-day retention. Now, somebody out there is going to be like, Jessica, that's not true. I have an image. It's a logical image of a Safari DB, and there are dates in there before 30 days. I agree with you. It can happen. You don't have all that data, and I'm going to tell you why. Let's say you're continually going to the same website. Let's say every single month you get paid twice a month on the 15th and the 30th, and the 15th and the 30th of every month. You don't use a banking app because you don't really care about your own security. You just go through your browser. And on the 15th and the 30th of every single month, you check your bank statement. So guess what? You've never left that 30-day realm of not touching that website because you check it every 15 to 16 days. And sooner in March because we know that February is shorter. Yes. And you're checking it twice a month. So you're never going to exceed that 30 days. So it may have dates going back to the first time you went to that website because it never lapsed that 30 days. But any other website or URL that's been visited that's gone past that 30 days will drop any instances after 30 days since the last time that site's been visited. But it will retain history longer if the site's been continually visited without ever exceeding 30 days. So I know that'll sometimes drive folks crazy. Deleted photos, 30 days, after 30 days, they're gone. Now, this isn't 30 days from when you seized it. It's 30 days from when that delete button was hit, which means every single day, your database is dropping information. This means every day, even if you've got that battery pack on because you're keeping that thing in after first unlock, every single day that it sits on your evidence shelf, you're losing data, including Knowledge C data. And Knowledge C data, all of those, please go look at Sarah's Mac4n6.com or her previous presentations at places like the Sandskeefer Summit. And you will see all that great rich data. Those artifacts vary in length between 7 to 28 days for how long they hold. And every single day you're losing data. Your cached locations, very rich data set of geolocations. Every single day it's dropping data. Your call logs, that data is dropped continually. It does vary by carrier how long it's happening. But just to know that every day you wait, you lose information. So now it's not only critical that you keep power on those iOS devices, and actually any device. If the device is in an on state, keep it in an on state. Rule number 1 of mobile forensics, keep her on, but acquire that device as soon as possible. Every day you lose data.
Absolutely. So now let's touch on how we can determine if our tools are failing us or we're not getting what we expect to be getting from these devices.
Because they're going to fail silently, right? So
Mhm.
how do you determine? Well, there's a couple things, and Cesar really hit on this before, and it's about listening to the community, and Twitter is where the community is. So people may think it's silly when I'm like, go use Twitter for digital forensics. If you follow hashtag DFIR, now I am not saying you have to talk about what you had for breakfast. I'm not saying you have to talk at all. Twitter is the easiest place to have a lurker account. Just create an account, associate it with a Proton mail. I don't care. And just check out hashtag DFIR. That's
how we all
where
start.
everything is happening. We all start there, and then we become braver, more brazen, and we start
Yes.
talking and we connect with the community.
Yeah.
And regardless, in addition, so people tweet and share all kinds of information. Another place or thing that practitioners do is they blog about their research. And if you are finding out anything or researching anything, I don't care if you've been in digital forensics for 10 years or 1 week. If you can, by the limitations of your organization, share in a blog, I encourage you to do so. There's about 200 plus pieces of information put out by this community every week. And Phil Moore does a fantabulous job of making a collection of all of that on a website this week in forensics. He's an Australian, finishes it by the end of his weekend. So it's good Sunday morning reading material for those of us in North America. And it is what I would consider my required reading every week. I go through and I figure out what's happened. But not only that, because Phil's been doing this for over 5 years, you can go into This Week in Forensics and search for something. So let's say you've come across that surface and you don't know how to acquire it. Or let's say you want to look for that presentation from Courtney Webb. You can just put it in the search bar there, and This Week in Forensics serves as a sort of Google for practitioner-created content for the community. And then another place, if you want to know the conversations happening today about what's happening in digital forensics, the Digital Forensics Discord server has over 10,000 forensics examiners having conversations on every category imaginable in digital forensics today. So please, please, please be sure to check that out to hear and learn what else is going on. And again, use the search function. Ask your peers. If you're seeing something and it doesn't make sense, ask your peers. And then the number one thing is to test, right? Because how do you know what you don't know? And that's through testing. So the first thing you have to do in order to test successfully is have an exemplar. There's a variety of ways you can do that. In some instances, it may be appropriate to do this in virtual machines or emulation, or even in spun up AWS instances. I've done that even for some Mac testing, because it's cheaper than just buying new Macs. Or you may be using Corellium for iOS, or you may be using BlueStacks, or you may be using regular VMware, whatever your VMs of choice or what's appropriate for creating your environment, or you may be using physical hardware. Very, very hard to test geolocation data on emulation. However, you have to have exemplars that match your situation, but you also need to think outside the box. For example, if you're looking at the adapter scenario and you're always using the same adapter and you're not seeing if something differs, if you use the native equipment versus post-manufacturing equipment or something specifically meant for acquisition, you may not know. So the most important thing is knowing that you have to have exemplars that match your situation, but also go to step beyond and say what if. And you need to research, right? You need to look at the information that's out there about those devices. If on that phone in which we got that 1 gig physical image on that case that Cesar and I worked, had we not done as part of our routine research to ensure that we were getting full collections, we would have never known that that other 16 gig eMMC was there, that the tool was unaware of, and we wouldn't have gotten that rich data set back. Now, this can include things like just looking to see if there's SD cards in the port on a Chromebook, right? Like you might not think of a Chromebook as a device with a port, but they have SD card ports. And You just don't know if you don't look. So expand your knowledge and ask the questions about what is, and in most of these instances, what is the true and most complete data picture I can get? Again, realizing there are appropriate circumstances for triage, but what is the most complete picture I can get? And then populate a device and see if you can get it all. Because when you're working with knowns is when you're able to do things. Because if we look at data and we make assumptions, that's okay for a hypothesis, but we need to validate it. Does that timestamp mean what you think it does? Is that collection complete? It's just the same when we're looking at collections. You have to question and test.
Right. So to wrap this all up, in summary, what we want you to take away is that triage images are valuable, but they may not have all the data you need. You may need additional information to piece those puzzle pieces together. So we advocate for a full file system when possible. And once you have an image, you may not have another opportunity at it. So make sure it's complete, make sure it's not encrypted, make sure that image opens up in your tool and you can see everything just fine.
I can share a little horror story there in terms of BlackBerry
Absolutely.
physicals, right? So getting the most complete image is not always the image you need. Just to go back against ourselves. I was working a case, got a black tales from the failures, right? Got a full physical on the case, thought I was good to go, sent the phone back, and realized that there was no parsing support for that full physical image I had gotten.
Yeah.
Right? So needed to go and request to get the device back so we could make a logical, so we'd have a starting point at parsing. Yeah.
We've all done it. So tools may not be self-aware that the collection is incomplete, right? In the example of the Android, the tool thought it was complete. It gave us the 1 gig. However, it was completely missing that 16 gigabytes of data. So your tool only knows as much as it knows. It's up to you as the examiner to do your due diligence and to make sure you are getting what you expect to get. And that means going through the websites, going through manufacturer pages, just to make sure you have all the data that you expect to get and not just relying on the tools.
And this is why it takes an examiner, not automation.
Correct. The examiner's knowledge is critical. In the example of the Surface, we saw that it was a brand new device on the market. We had no way to acquire it, no support. However, we relied on somebody who was a bit more experienced, who was willing to share their knowledge with the community. And, ever since then, we've been able to acquire Surfaces going forward. So, you should rely on the community, rely on those who are more experienced, and it'll help everybody in the long run. And as Jessica mentioned, the state of the device at time of acquisition is important so that you know what you expect. The AFU, BFU, logical file system, you're going to expect different pieces of data to come out, and you just want to know what kind of state it is. And if it's an AFU, you want to make sure to keep it in that state. So you're not going to be locking yourself out of potential data down the road. And finally, time from seizure to acquisition is vitally important, because every day you let that device sit, on your desk and you're not acquiring it, you could be potentially missing vital information. Even if it's in airplane mode, or if it's in a Faraday bag, or you have it, powered on with a battery and it's always on, every day that you're leaving that device alone is a day that you could be missing data, because that device is auto, deleting stuff from you.
And that's actually a good reason to, if it is AFU or BFU, to even before you start the process of trying to crack a password to get a full file system image, that you get that AFU or BFU image first, just for that data that's going to be from those limited databases, especially if you've still got it after first unlock.
Absolutely.
And with that, we would direct any questions you may have to the best place to get a hold of either of us, which is via
Yes.
our Twitter DMs. So we welcome and would appreciate questions. Additionally, if you'd like a copy of this deck, you can either scan this QR page, or if you go to hexordia.com and hit the Present Presentations button, it's right there at the top. Just click on the picture that has our pixelated pictures from the Sans Defer Summit where we first presented this material, and you'll be able to pull a copy of our slides.
Yes, absolutely. Yeah. Feel free to reach out to either of us. We're always willing and able to help whenever we can. So please do.
Thanks, everyone. Bye.
Bye.